just wanted to make a video basically doing kind of what we did yesterday, but getting a little further into it and talking about the figures and also talking about, how to incorporate the figures into your reports and also what, the expectations around how to talk about those figures in your report. So first, I'm just starting with opening up Rstudio. And I have nothing open so far, so the whole panel is just this console page. And the console is where we, can actively type things, right? So what the first thing you want to do when you open Rstudio is to first open the R script from our class files. So I'm going to search for that. I believe it's this rnaseq.de.bioinformaticsclass.r. So that one is available on the Canvas page. So once you open the script, it's going to pop up this window up here. And so you're, as it says in the notes, you're currently viewing an R script. So it's good practice to run it line by line, just so you can see, if a line goes wrong, you can see what happens. And so we can either run lines by using these key controls on Mac or Windows, or we can sit our cursor on a line and hit the Run button. We can also select a whole block of text and run that, and it will run everything that's selected. So the first thing that we are going to do that we spent time on yesterday was setting up our working environment. So first, you need to locate where your reads per gene files are. Wherever they are on your personal computer is the address, the path you're going to put in between quotes here. So if you're having trouble with this, another kind of way to do this is to write down a path that you know and then move your reads per gene files into this directory. And you can test whether this line here worked by running, I believe, line 70. I'll scroll down here. So yes, so line 70 is what uses the grep command. Remember our familiar friend grep. You can also use it in R. You can also use it in Python and other languages. You see when I hover over this, it tells me kind of what should go in this command below it. And so when you run this command right here, it's going to grep inside the folder that you told it to on line 24 and look for any files with this in the name. So if you happen to name your files something slightly different, you will also need to change this, but I think most of us have the same file name. So if you run this, I just did that by hitting Command Enter, Command Return, but you can also just sit with your cursor on the same line, anywhere on the line is fine, and then hit Run, and you'll see that either way it runs it down here in the console. So this command is finding the files that have this in them and then assigning it to a variable called sample files. And you can see in this environment, right, this environment area, we have something called something called sample files. So we can check that even further by just typing in the name of the variable on the console, and you can see that because it exists, it pops up as a suggestion, kind of like tab completion. So you can do tab completion in R as well. So I'm entering this variable on the command line, on the console, just to see if it did what it was supposed to, if it found these files. So yep, it's found these 6 files for me. If it's saying that this variable doesn't exist, that means that it didn't find the files. So that is a case where you can go and find these files on your computer and just put them in the location that's mentioned on line 24. And they should be available there. So that is the way you set up, how R and Rstudio can find the files that we're going to be working with, because these are all of our input files, right? These files where the first column is gene names, the second column is number of RNA reads that have mapped to that gene. So the next part in setting up our environment is installing and loading packages we need. Packages in R are like little software packets that you can install and load in. And these can often be, like we said yesterday, the trickiest part of working in R. So It's probably best to run these one at a time as well, just so that you can see if anything goes wrong. So I'm going to put my cursor on one at a time and hit Command Enter to have these start installing. So some of you may have gotten errors that said that you don't have writing permission, or the directory is not writable. It seems like that's actually fine, and you can keep moving on in the script. That seems to be a permissions effect that is not consequential to this script, luckily. So I'm installing these one by one. You can see that most packages in R can be installed with this install.packages command. And I have a little explanation here. Not all packages are going to be available this way. Some packages also will say, this package isn't available for this version of R. That's not always actually true. Oftentimes we can get the package from another database, of another repository, called BIOC Manager. So that's what's happening here, is we're installing BIOC Manager, which is another database, another repository, where we can install programs like DESeq2, Cluster Profiler, this human database that we'll talk about a little later in the script. All of these can't be installed through the regular, and they need to be installed through BIOC Manager. So it's asking me if I want to update loading my packages. I don't find that makes a huge difference, so I'm going to say no. If you're having issues with it, usually restarting R is a good thing to try. If you need to restart R, you can go up to the top here in this Sessions and say Restart R. So I can keep running these. I may need to actually add a line here. It seems like everyone's is working fine without it, but installing packages and then loading them in as a library are different. Loading them into the package library that you're working in are different. So sometimes we also need to call this. But I think it's actually working fine. So you see down here it says update all, some, or none. It's showing me a list of packages that this program that we are working on installing is dependent on. So it needs those packages to run. This is where you often run into issues in R because there'll be incompatibilities and version issues with packages. It's saying these are old packages and it's not happy about that and asking me if I want to update them, and I'm going to say no. So I'm going to hit N and hit Enter. Sometimes it's the case that we need to update those. Oftentimes it's not. So if you have issues with downloading these packages, if they say failed or if something's really not working, you can go ahead and send me a screenshot. And one thing to try might be you can Google BIOC Manager and then the name of the package. And you'll find a web page at the very bottom where you can download this software just like you would download any other software from an internet browser. And you can go to this Packages tab here and hit Install. And from here you can see the path, right? These are a path and address that we're used to seeing by now. You can see the path of where R is looking for software packages to use in this library. So you can copy this address or just move that installation into this library. If that happens, we may need to troubleshoot some more, but that's just an alternative way to troubleshoot if the packages aren't working. So I am running through all of these. They are installing. And once these are installed, down here is where we're loading them in. So you only need to install packages once, but you will need to load them in as the library every time you open this script. So if you open this script as new, you will need to rerun these library lines to just tell Rstudio to get those packages ready to run. You can see that this last one is taking some time. That's because this is actually a human genome database that's running, so HSDB. that is the Human Genome Database that is going to tell us about what biological categories our differentially expressed genes are a part of. So that's why it's taking a while, is because it's a fairly large database. I mean, it's not actually large. It's like 80 megabytes, but still, that takes a little bit for Rstudio to connect and download. What it's doing here is connecting through this BioC manager to this database, bioconductor, where these packages are stored. So we're just installing software for now. And again, I'm going to say I don't want to update packages, so I'm going to say no. So now I'm going to run these, and I'm just going to kind of do them one after the other. You can see that some of them give you messages back. Some of them give you citations to use, which is really nice and convenient. I haven't really emphasized this in this class, but anytime we're using tools, we should be citing them. So I'm not going to be a stickler about that, but as you're going forward, if you do research, know that tools should be cited as well as data sources or just regular sources that you're using to inform what you're writing. So you can see it's saying conflicted packages is a problem. That happens when multiple packages have the same named functions. So all of these are little functions, little commands. Sometimes if packages have the same ones, same names, it'll say conflict. The way that you specify which function you'd like to run from which package is to use these double colon. So here, for instance, if I were needing to use the slice command and I wanted it to come from dplyr, which is a kind of data manipulating package on here, I would need to specify the dplyr version with this double colon. So just a little bit more info for anyone interested. So there's some information here about if a package fails. Again, you may not know it until you try to run commands later on in the script that use these packages. So we won't know if DESeq2 loaded correctly until we run it on line 92 is when we first use a DESeq command. So we'll find out when we get there. If there's issues, you may want to restart R, like I said, or just kind of try to reinstall and reload the libraries. So the next part of our data is gathering the input data and formatting it into a table that tells us about which patient it is and what condition the sample is. So whether it is a cancerous sample, represented by C here, or an N for non-cancerous or normal. So again, we ran line 70 above. This line is finding the files in our directory. So I'm going to first run those, and we already know that it worked, but you may want to check again on the command line. Sorry, I keep calling this the command line, the console. It actually does have a terminal window where you can run a terminal just like anything else, but we don't really need to use it here. So the next part is just doing sample names. We're subsetting just the SRA IDs, so the IDs from the SRA database. Just want to have those sample names so that we can label our files without labeling them with the whole file name. So the next part is we're loading in lists of conditions and patients, and then this line is going to put that all together, the sample names, the condition status, and the patient status, and it's going to format those all together. So I'm running these. The sample names is going in. Sorry, the sample names is just reformatting them again. The sample table is what is gathering up this data and putting it into what's called a data frame in R. And a data frame is a very typical data object type in R. It's probably the easiest to work with outside of like lists like this.